This is our Math 1 idea talk on the topic of visual routines promoting equity and inclusion. My name is Jennifer Fannin. I'm a teacher at the Elms Junior Middle School in the TDSB. Starting with our land acknowledgement, we acknowledge we are hosted on the lands of the Mississaugas of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit peoples. Another acknowledgement is that several teaching strategies within these slides, concept attainment and concept circles, are discussed in the books Teaching Math with Meaning and Math Expressions by Dr. Kathy Marks-Kripan. Her books are important reads for any teacher interested in implementing visual strategies to promote deeper mathematical understanding. Also, the routine of which one doesn't belong originated from the book written by Christopher Danielson. See the last slides for details. Why visual routines? By using visual routines, we draw on students' prior knowledge, remove language barriers for ELL students presented by traditional word problems, present open problems that value multiple strategies for solving, help create non-threatening provocations that students feel comfortable taking risks in solving, and allow opportunities to think across strands in math. The visual routines that will be covered are the same different routine, which one doesn't belong, concept attainment, and concept circles. Starting with same different. What is same different? It's a math routine that allows students to share what they know about two different images, explaining how they are the same and different. Why use same different? This routine provides a prompt for students to use critical thinking skills to explain their understanding and solve problems. It's an excellent way of spiraling and reviewing their knowledge across multiple strands. As you can see from this example, I used just two simple sets of Lego and took photos, and we were saying what was the same and different in my grade 3 class several years ago. The discussion became very rich. We ended up talking about not only geometry, but measurement, number sense, area perimeter, symmetry, multiplication and arrays. So you can see how one simple prompt or provocation like this can lead to a lot of different math concepts being reviewed. Here's another example coming from the same different images website. This primary example is more related to the number strand, could be used for multiplication, repeated addition, division. This example is from my own practice again. It is a simple screen capture of different graphs, and we used it to discuss data-related topics of central tendency, distribution of data, etc. And this is an intermediate example, which could be used to bring up topics surrounding linear equations. How to create same different routines. On Google Slides, you could cut and paste images in. Using Google Slides allows you to record student thinking directly on the slide. You can create these images using photos of real manipulatives or on a virtual manipulative site, such as Math Learning Center or Braining Camp. You can also access pre-made visuals from the website Same But Different Math or Same Different Images. The next routine to be discussed is which one doesn't belong. What is a which one doesn't belong? It's a visual routine where images are presented in one of 4 quadrants. Students are asked which image does not belong and provide a mathematical justification. It should be emphasized that there is no one right answer or wrong answer as long as student thinking is communicated. Why use a which one doesn't belong? This routine asks students to use their prior knowledge, synthesize what they already learned, and communicate their understandings. Here's a primary example that I created simply on Google Slides using different images from the internet, focusing on financial literacy. And as you can see from the example, students might pick the loonie, right? They might pick B and say that doesn't belong simply because there's only one coin. Some other students might say C because there's the most coins there. Some would add up the money amounts and use that as their justification. So you go in many different directions with the one provocation. Here's another which one doesn't belong, which actually is quite rich because of the different colors. I created this one just using a simple virtual manipulative. This one went in the directions of we ended up talking about multiplication, fractions, area, perimeter. Quite a lot of different topics came out of this discussion. Here is an intermediate example, which you could use to discuss topics around algebra. How to create a which one doesn't belong routine. On Google Slides, you can cut and paste images. You can also create using real manipulatives or on virtual manipulative sites, as mentioned before. You can also access pre-made visuals from wodb.ca. Next is concept attainment. What is concept attainment? It is a routine where students are shown a series of images that either follow a rule, yes, or don't follow a rule, no. They're given opportunities to guess the mathematical rule used for each column and then explain. Why use concept attainment? This routine asks students to use their prior knowledge, synthesize what they already learned, and again, communicate their understanding. When I introduce concept attainment to my class, I always start with something non-mathematical so students can have easy connections made. So in the yes column, I would first show this eraser. In the no column, the car. Again, we would move very slowly through each image or each provocation, giving students time to turn and talk, to think, pair, share, and then get back to us as to what they thought the rule could be. Then we have a pencil. The yes column, no column now has a monkey revealed, tape for the yes, etc. And towards the end, we have students guess at what the rule for the sort might be. And at the end, we show that it is indeed school supplies for the yes column and not school supplies for the no column. Here's another primary example. I'll move a little faster in the reveal, but you would move slowly. So we would show them that the yes column, the rule was greater than 200, and no was the not greater than 200. Here's a primary junior example using 2D shapes. The yes rule is has a right angle, and the no rule is has no right angle. An intermediate example for algebraic equations. The yes rule being that the coefficients are different, but constants are the same. And the no rule being that the coefficients are different, but constants are not the same. So how to create concept attainment routines. You would cut and paste images, but you would do so as separate items in Google Slides because we want to reveal them one by one. We'd use the animation feature on Google Slides to reveal one clue at a time. We reveal items slowly and with intention, so as to allow for multiple possible rules and promote discussion between revealed items, and ensure that the rules for sorting are revealed last. The last routine that we'll discuss are concept circles. What is a concept circle? They're circles with a central part or prompt and an outer ring divided into smaller sections. In the smaller sections, learners can show different representations of a concept. Students can then show their representations using diagrams, words, numbers, or manipulatives, depending on the nature of the task. Circles can be divided into many different sections as well, so you're not forced to just use the 4 sections that I have on the screen. You could have 6, you could have 3. They could be open, meaning that there are no prompts on the outside sections, or closed, meaning that they do have prompts. Why use concept circles? Concept circles help students make meaningful connections by asking them to represent a mathematical concept in more than one way. Students are asked to use critical thinking skills to come up with different representations and work collaboratively to solve the problem. Effective communication of their solutions to others is an important learning goal of any concept circle. So here's an example of a more open concept circle for primary. We have the number 31 in the middle, and we're asking students to show the number 31 in as many ways as they can. So relating to number representation. Here's one way that students could solve, but you might find that students solve differently in different quadrants. Meaning that maybe they're going to use words in one quadrant or repeated addition. I'm a big fan of Lego math, so here's a Lego math related example. So if an 8-peg Lego piece is a whole, how can you represent the other fraction? So this is more of a junior example, and it's more closed because, as you can see, there are provocations in the sections around. Yeah, you can see it relates to fractions, decimals, percentages, right? And here is another intermediate example related more to algebra again and variables. So if X is a 4-peg Lego piece, how could you represent 2x, x plus 1, 2x plus 2, 3x plus 2? And these might be different ways that we would represent. Here's a many example just to show that there are different ways that you could use a concept circle. So other applications might be decomposing shapes for spatial sense, converting measurements in spatial sense, representing money amounts, and making change in financial literacy. How to create concept circles. For classroom use, we could definitely use a concept circle template. Printed out on 11 by 17 paper. Some teachers even laminate so that they can reuse. They could write it and then write a prompt and have manipulatives readily available for solving if students decide to use manipulatives. If we're using the virtual version, we could, again, create the concept circle template and then cut and paste other virtual manipulatives into your slide. Write a prompt for the top portion if required, and write a prompt for the outer segments. Book resources you may find helpful. Math expressions, developing student thinking and problem solving through communication. Teaching Math with Meaning, both by Dr. Kathy Marks-Kirpan, and Which One Doesn't Belong by Christopher Danielson. Also, some websites you might find helpful. Which One Doesn't Belong, Same but Different Math, and then Same Different Images. Thank you so much for listening to my short presentation. I hope you have an amazing school year. And my Twitter handle is on the screen in front of you. Okay.